¿Qué tal? Buenos días. Muchas gracias por estar en esta.
Good morning. Thanks for attending this meeting. We are going to listen to Chad Lee's talk dealing with how no-till and management changed soil conditions in Kentucky State. Chad Lee is a researcher. He had a bachelor in agriculture, and then he had a master's degree in agronomics and a doctorate in soil sciences in Michigan. He's an extensionist and grain professor at the Kentucky University and director of the new Grain and Forage Center, a $30 million investment for research and mitigation in agriculture in Kentucky. This research center is based in intensive agriculture and environmental quality. Chad Lee also leads research projects applied to different crops under the no-till approach, where soil quality is as important as obtaining high yields. Dr. Chad Lee also leads extension activities throughout Kentucky and teaches graduate and postgraduate students. He has visited numerous times Argentina and has lived elsewhere with his family, and though not speaking any Spanish. When visiting Argentina, he visited different groups, the Aapresid offices, as well as attended meetings organized by different associations, and he has led three farmers groups that have visited Argentina. Let's now listen to his talk, and whatever questions you may have, we will entertain them at the end of the talk. Let's watch the video.
Hello, I'm Chad Lee at the University of Kentucky. Today, it is my privilege to talk to you about cover crops in grain systems. So at the University of Kentucky, I'm an extension professor, which means I do some research, a little bit of teaching, and I spend a lot of time working with producers, agribusiness professionals, crop consultants, county extension agents, and others on delivering information from the university research that we do to people that can actually use it and hopefully improve their livelihoods in the process. In my area, I'm an agronomist, and I work in corn, soybean, wheat, rye, and some barley. I'm also the director of our Grain and Forage Center of Excellence, which is a very new group that's an exciting group to work with at the University of Kentucky. And you can find me on Twitter at Kentucky Crops. You can also see recently we took a group of farmers to Argentina and got to visit with one of my colleagues, Lucas Bordas, and his staff and students, and then also several farmers as well. I've been fortunate. I've been able to visit Argentina several times since about 2009. Met a lot of really good people, made some really good friends. And we've also benefited from having a few students come work for us, either as interns or as graduate students. And I apologize to those that aren't on this screen. There are many, many more people that could have fit into this particular image here, but I really appreciate how well Argentines are trained in agriculture and agronomy, and I appreciate your kindness and generosity. Over the years, one of my regrets is that I've not been able to learn Spanish in that time frame. Now, my wife learned Spanish in school, and when we were in Argentina as a family, she picked it up pretty quickly and went very well. In my case, I learned German in high school. I can't speak it either, so at least in that one regard, thank you very much for letting me give you this presentation in English. And I apologize that I've not yet learned the Spanish. So for those that may not know, Kentucky is just south of the states of Illinois, Indiana, and Ohio. It is just north of the state of Tennessee. It is where the glaciers stopped, and that makes most of our landscape very undulating. So we have a lot of hills and valleys, rivers and streams. And in southwest Kentucky, in the 1960s, no-till really began in earnest right here. It's one of the very first cases of no-till anywhere in the world in a commercial production. Now, our main campus is in Lexington, Kentucky, which is in the bluegrass region. And if you've seen thoroughbred horses or anything like that, that's where those horses are raised. And then we have a research station out in Western Kentucky that's actually very close to where those first no-till fields were grown. And that's a lot more row crop agriculture. So corn, soybean, and wheat is grown out in that part of the state. And I work at both facilities a lot. In fact, at Princeton, we just opened a new 3,700 square meter building. It's a renovation and expansion. We have over 60 professors, grad students, and employees that work at that station. We have many departments represented, and with the help of our Kentucky corn growers, we have added 100 hectares of excellent soils for more additional grains research. And so we're very excited about some of those developments. Now in Kentucky, we grow corn and no-till. That was the first crop where no-till got started. We also do no-till wheat, and we do no-till soybean. And like many in Argentina, we do corn and then wheat and then double crop or second soybean. In fact, a lot of that a very original double crop or second soybean research was done at Princeton and in that region of the state. And we all know right now that no-till reduces erosion on undulating fields, which we have a lot of. And then we also have a lot of fields that have rivers and streams and flowing water that make up their borders. And so protecting water is extremely important to us. And this is a stream early in the spring when the rainfalls are heavy, but there's no summer crop planted yet. And yet the water's coming here that's clean. And that's one of our goals of no-till. It's also one of the goals of cover crops. We want clean water. We need clean water. People will use this water for drinking purposes. Cities use this water. And then some of this water also goes into other products like, like bourbon whiskey, for example. This particular picture was taken about 15 kilometers from where one of our major distilleries is located. As I mentioned, no-till began in the 1960s, actually 1962. Harry and Lawrence Young out in Western Kentucky did some experiments with it. The University of Kentucky came along very soon afterwards. This is that original no-till field that they tested it out in. Harry's son, John, and his grandson, Alexander, now farm that land and manage that area. And so this image was taken about 3 weeks before soybean planting that year. And in this case, the winter annuals are providing some cover, but that's not what we're talking about when we talk about cover crops. And so I just want to reiterate that a farmer started no-till first, and then the University of Kentucky came along and worked with that producer, and then many, many other producers in Kentucky to help get no-till started. Some of my colleagues, predecessors, also spent time in Argentina as well. The very first commercial no-till planters were made by Alice Chalmers. And the gentleman in the blue shirt, his father owned an Alice Chalmers dealership where they sold equipment. And they helped Alice Chalmers design the first commercial version of a no-till planter. The gentleman in the plaid shirt was a farmer, still is a farmer, but at the time, he bought one of the early versions, one of the early models of a no-till planter. And recently, a group of students restored that planter, and this farmer donated it to us to keep it at our Grain and Forage Center of Excellence as a reminder of our heritage and the importance of no-till agriculture. If it wasn't for no-tillage, we wouldn't be able to grow corn and soybeans anymore. I'm absolutely convinced of that, as are many of the farmers in this area as well. Of course, planters have changed some over time. They've gotten much, much larger, much more sophisticated. A small company just very close to Princeton named Martin Till got started using row cleaners, and you can find those all over the world. I've seen them in several barns there in Argentina. And then also spike tooth closers sometimes will show up on the back of planters. And the long story short is we've really figured out how to handle residue from a no-till perspective. We may have some more things to learn if we start to bring cover crops into the equation. But back on the no-till, so we've conducted studies in the Lexington area for over 40 years where we've had the same plots of land in no-till or moldboard plow till. And then we've also had sod close by. And what's happened is over that 40-year period, soil organic matter has increased in the no-till and in the sod areas. But where we've done continuous tillage, that soil organic matter dropped and then has maintained a low level ever since. And so using no-till helps build soil organic matter. Also, sometimes you will hear people say, well, that if you get high yields, that will deplete your soils and wear out your soils. Well, this data shows us that the higher nitrogen rates that we use, the more carbon we actually retain in the soil. And that's because in this system of no-till, it's continuous corn, which we don't recommend, but it's also got a cover crop every single year. And so those higher nitrogen rates are giving us more total biomass in the corn and in the cover crop. And that combination is capturing more soil carbon. So if we're going to grow crops, we have to have nitrogen in order for those crops to grow. Now, often when we talk about a cover crop, we're wanting it to capture what's left over. And in this case, that's exactly what's happening. When we apply 150% above the agronomic optimum nitrogen rate, that cover crop is capturing some of that excess nitrogen, and that's adding biomass, which is adding better retention of soil organic matter. So as I mentioned before, we do the 3 crops in 2 years. We do the corn, wheat, and soybean rotation, where we do double crop soybeans. And it's after we harvest those double crop soybeans that we have an opportunity to plant a cover crop. And in many of the situations that we're studying, that's what we're studying, so that we have some sort of active root system growing in the field during winter. And I think that's extremely important. Now, we also have some fields that aren't suited for wheat, that don't do well with wheat. In those fields, they're in a corn soybean rotation. And those fields are candidates for a cover crop every fall. It wasn't long after we started doing no-till research at the University of Kentucky that my predecessors began to do some cover crop work as well. And at that time, they were primarily focused on legumes. And they wanted those legumes to donate some nitrogen to the corn crop. And in those studies, what they found is that they had to let those legumes grow very late into spring and into early summer, and then plant corn very late behind that in order to apply or supply enough nitrogen for the crop to grow. It was a system that worked from the standpoint of providing nitrogen. It didn't work in that it forced the corn to be planted late and resulted in much lower yields. And once oil prices dropped back down and nitrogen became cheap as a form of fertilizer, farmers were not interested in giving up that kind of yield for those kind of benefits. But as they did that research, they also noticed that that early research, it helped reduce erosion. They reported that the water coming off of those areas where they had a cover crop was cleaner. And this is compared to another no-till system where you didn't have the cover crop. And then their later reports also said that they included a better soil structure and overall better water holding capacity, which is so important for us. Our soils are shallow. They're very, very shallow compared to what you grow in the humid Pampas region in Argentina. And so for us, anything we can do to hold more water in our soils during the middle of the summer is usually a good thing. Now, the other problem that we do have in a lot of our soils is that in the spring, when we're trying to plant corn, our soils are too wet. And so we can actually have too much water during planting, and we can end up with too little water when that corn is trying to pollinate and go through the early stages of seed fill. So sort of full circle, our predecessors have retired and moved on, and a lot of us that have come back in are now doing more cover crop research at the University of Kentucky. And I would encourage you that if you're very interested in cover crop research over the next couple of years, you should start to see a lot of research papers from the University of Kentucky coming out with these various names on them. Hannah was the one that's publishing some on the long-term no-till plots. Aaron's doing a lot of work in weeds and weed control, weed suppression with cover crops. Edwin and Josh do a lot of work in fertility. Bob does a lot of work with cover crops and tobacco and hemp. And Kirsten does a lot of work in plant pathology, so looking at diseases and disease pressure from cover crops. And there's some others as well that have since done some cover crop research. So it's a pretty exciting time to look at cover crops in our area. And the predominant cover crop that most people are growing, most of our farmers are growing, is cereal rye. Cereal rye, we know will reduce erosion, and part of the reason that cereal rye is so preferred over other crops is that it has a very, very active root system. And so in this case, you've got 18 centimeters of shoot growth and you have 46 centimeters of root growth. And this is typical. So you have a very aggressive root system, which will help pull in excess nutrients. It helps to hold the soil in place. And it's more vigorous than almost any other winter annual crop that we can grow. And so that's why there's a lot of research on rye. We plant it at about 60 kilograms per hectare. That's about how many seeds per hectare we try to plant. We put it in immediately after soybean harvest. And then our best balancing act of managing this in the spring is to terminate it at about 14 days before we plant the corn. Now, some farmers want to go later with that. Some want to go earlier. And I'll talk about some of that in our research. One of the challenges with a cover crop is residue. That's one of the benefits, but it's also a challenge. When you have a lot of residue and you have cool, cloudy weather during the spring, little animals like slugs are sort of like a snail without the shell. Slugs will come out and they will eat the plants. And in this case, they have destroyed the plant density in this field, which forced this farmer to have to plant corn again. And then here's another animal called a vole. Now, a vole is similar to a mouse. They'll hide in the residue and they'll eat these soybean plants and sometimes corn when they're very, very young. And in this case, they can cause some devastating impacts on a field. And so we have challenges with residue in terms of other animals that it might harbor. We have some farmers that have chosen, they want to go much, much later in terminating that rye, and they want to terminate it basically right when they plant. Here's a farmer that applied herbicides 3 or 4 days before planting. This picture is taken 1 day after planting. And so the herbicide effect isn't noticeable yet. But you come in 18 days later, the farmer ran a crimper over the field, so he pushed all that rye down. And now you can see that it's controlled the cover crop, but now the question is, can the corn make it through? And in this case, the corn is coming through, and I would consider this very high risk. It's high risk for things like slugs and voles. It's also high risk for diseases. But in this particular scenario, you move several more days, 47 days after planting, and this field looks absolutely beautiful. And so if you're a farmer that wants to terminate the rye cover crop late, this particular field is the field you want to show everybody. The problem is not every field looks this good. And sometimes we run into challenges. We may show you some of that in a little bit as well. Other farmers go on the other end. They say, well, I don't want that cover crop to interfere with the corn crop at all. And so they terminate maybe 4 weeks before they plant their corn. And they'll also do something like a strip tillage system where they're keeping all the residue out of the planting row and trying to get better stands that way as well of corn. And so you have farmers on both ends of these spectrums trying to manage cover crops, trying to keep them in there for soil protection, to prevent erosion, to capture old nutrients, but looking at, well, how do we best protect the field? So the farmer that has this field likes that rye cover crop because it should hold more moisture in the summertime. The farmer that goes with this method likes this because he gets a nice even stand of corn almost every time, where the cover crop isn't competing. And so those are some of the research things that we're interested in. The other issue is every farmer isn't quite sure exactly what amount of nitrogen they have to apply in order to overcome some of the challenges of a cover crop. With that much more biomass, that much more carbon being out in the field, there's some questions about that as well. And so several of us at the university met with several farmers, and we devised several different research studies. I think I'm going to show you just mainly one set of studies today, but I want you to understand that we are developing these studies in conjunction with farmers and crop consultants and county agents in mind. And in this case, I'm going to highlight the research from Dan Quinn. Dan is a PhD candidate. He came initially to work with me at the University of Kentucky. He's a really bright student. You can find him on Twitter. And then in May of 2021, so next year, he is going to start at Purdue University as their next corn extension agronomist. And I can tell you that Bob Nielsen and I both are ecstatic for Dan. Dan's full committee is ecstatic for him as well. And so we're excited to see him transition to finish up his PhD, get his dissertation written, and transition to that role at Purdue. And so be sure to check out Dan starting next spring as he starts sending out updates from Indiana on corn conditions up there. Dan's committee is me, it's Hannah Poffenbarger, Edwin Ritchie, and Kirsten Wise. Hannah is Dan's co-advisor. She has helped tremendously on the research component of his projects, on helping him get his papers written and his data analyzed. Absolutely critical to the overall study. All members have been very, very helpful in the project. And then I need to show, before we get any further, just some of our research crew. This was a couple of years ago. You've got Dan, Isabella, who's a student, an intern student from Brazil, James, who's a technician for us, Nicholas, who was an intern from Argentina, Ashley, who was a worker from Michigan, and then Julia. Julia is my technician as well. And Julia is from Argentina. She's a UBA graduate, and she worked for me as a summer intern one year, and then came back and got a master's with my program. And then thankfully, she stayed on to help me in a role as a technician. And she really keeps track of the research day to day. And I couldn't do any research at all without Julia at this point. She's absolutely critical to our project. Okay, so Dan's questions. His primary questions were, I've grouped them together in three overarching questions. One is, does corn following a rye cover crop require more nitrogen fertilizer? And if so, how much more? If we delay nitrogen fertilizer, will that reduce how much total fertilizer we need? And finally, do we need to plant more seeds per hectare, or do we need to include an in-furrow fungicide or a starter when corn follows a cover crop? And so we're going to look at those three basic questions as we go through. And so to set this up, the premise was we had cover crop that we terminated 14 to 21 days before planting. That's our normal recommendation. We had cover crop that we terminated the day of planting. So we tried to get it bigger to look like that one picture that you saw. Then we have no cover crop at all to compare. So that way we have really good comparisons with most of these studies. And then on that, we imposed treatments of in-furrow, which included starter fertilizer and a fungicide. We did different corn seeding rates, different nitrogen fertilizer rates, and different nitrogen application timings. And so we either did it at planting or we did a portion of it at side dress. And side dress is when the corn is somewhere around V4 to V6 growth stage. So that's what we were targeting there. This is looking at some cover crop that was terminated about 21 days before planting. You can see that it's not overly large, but it is still present in the field. And so that gives you some idea about what that crop looks like in that particular location. This is another location where we had a termination, again, at that normal timing, at that about 21 days before planting. This one had a little more growth in it, but that gives you some idea about the kind of residue we're planting into in those particular conditions. And then this is what the rye looks like when we terminate it the day of planting. So much taller, much more biomass that we're pulling off in those fields. And then this is a look at some of that corn and that heavier residue later, a few days later after emergence. So in this case, Julie has also pulled some biomass samples. We got biomass samples from all of this to look at the carbon nitrogen contributions. We also pulled soil samples so we can understand what was happening in those dynamics. And if you look at the overall biomass, so I'm just showing you about 2 years of data so far. So Lexington in 2018, Lexington in 2019, Glendale, which is between Princeton and Lexington in 2019, and then Princeton in 2019. And what you can see is we had very low biomass the first year at Lexington. We had good production levels of biomass in 2019 at both Lexington and Glendale. We had very low biomass at Princeton in 2019. Now, Princeton in 2019 gave us all kinds of problems. We had difficulty getting the rye planted because it was so wet in the fall. It was very wet in the spring, which made planting corn difficult. And then it got very dry, right about R2 to R3 growth stage on corn. And we were dry from there on out. So we had challenges at Princeton all season long at that location. But you can see the total C, the total N, and the C to N ratio. And somewhere the lower yielding material was about 15 to 1, and the higher yielding locations, the C to N ratio is about 19 to 20 to 1. And so in theory, those two higher C to N ratio spots, locations, should require more nitrogen overall to help break down the biomass, the carbon in those areas. And so one thing we looked at was agronomic optimum nitrogen rate, or the AONR. And in this case, you simply look at various rates of nitrogen fertilizer on the x-axis, and the y-axis is grain yield. And somewhere where that line starts to plateau or even out, that's where the agronomic optimum nitrogen rate takes place. And so what I'm showing you now is, of those 4 site years, those 4 environments, we have bar charts that are showing you the agronomic optimum nitrogen rate, the AONR, for each scenario. And so we've got grain yield in kilograms per hectare, or excuse me, the nitrogen rate in kilograms per hectare that we needed, the agronomically optimum nitrogen rate that we needed. We're looking at no cover crop and the rye cover crop. And then the red is a starter fertilizer plus pre-plant nitrogen. Now the starter was about 3 kilograms of nitrogen per hectare, a very small amount of nitrogen, a little bit of phosphorus as well. The blue-green bars are the starter plus side dress. And so in this case, we put the starter on, and then all of the extra nitrogen went on at that V4 to V6 growth stage. And so if delayed application of nitrogen works, we should have a lower AONR when we side dress. And that's what we see in 6 out of the 8 comparisons on this slide, is that in most instances, waiting to apply the majority of the nitrogen at V4 to V6 growth stage allowed us to use less nitrogen overall. It wasn't true in every scenario, but it was true in most. The other thing that we see is that on several of these locations, we needed a little bit more nitrogen when we followed the cover crop. And that should be more evident in the next slide that we go through. And so now we're just looking at that yield response to nitrogen. And this is averaged over the locations that had adequate water. So this one does not include that Princeton site that was very, very dry. But as you look at this, you can see the no cover crop is in that red, and the cover crop is in that greenish blue color. And as you look at our nitrogen rates, in this case, presented as megagrams per hectare, 0.1, 0.2, and 0.3, you can see that the no cover crop, when we have all of our nitrogen applied up front, the no cover crop always yielded better. So corn in the no cover crop situation yielded better than corn following a cover crop, regardless of nitrogen rate. These lines are essentially parallel to each other. They don't touch. When we go over to the split applied fertilizer, so we had the starter and then fertilizer applied side dress, at these higher nitrogen rates, we finally get to similar yields. But at the lower nitrogen rates, there's still a yield advantage to the corn that's following no cover crop. Now let me mention here, I should have mentioned this before, we are using a white corn hybrid. We have a good white corn market in Kentucky. All of that corn goes for food purposes. And we have several outlets right around the Kentucky area. And then we also export a fair bit of it to Mexico as well. And so we have a good market for white corn in our area. We chose white corn because it tends to be not as robust as yellow corn. It tends to be a little more sensitive to some diseases as well. And so we thought it might show us better distinctions in some of these things that we're trying to investigate. So I should have mentioned that up front, that this is all white corn. Okay. The other thing that is noticeable here is essentially our highest nitrogen rates applied overall resulted in our highest yields. And that's a bit surprising because what we are seeing in this study, and in this study only, is that the nitrogen rates we needed for maximum corn yield were well above our recommended rates of 0.12 to 0.2 megagram per hectare. 120 to 200 kilograms per hectare. So we're well above that. And we saw that we're well above it for both the system following the rye cover crop and when we don't follow the cover crop. So in both scenarios, we're well above it. We had, except for the Princeton, which we don't have in this data set, we had high rainfall at most of our sites. We were about almost 25 centimeters above normal both years at these other two locations. And so we probably dealt with more denitrification throughout the season than what we normally do. And that's probably why we see even the side dress applications requiring such a high nitrogen rate to get us up to maximum yield. Now, on the other hand, what we saw at Princeton, the dry environment, is we saw that if we delayed that cover crop termination to 1 day after planting, that we actually had more soil moisture retention throughout the entire season. The red line is looking at soil water content throughout following that cover crop that was terminated 1 day after planting. The green is no cover crop at all, and the blue is the cover crop that was terminated 25 days before we planted. And you can see all the way across from May to September, all the way through the growing season, the red, or the 1 day after planting, held more water in the soil throughout, which is really interesting, and that's a positive development. But unfortunately, as we see in this graph, when we delayed that termination of the cover crop, which is this column here, and this column here for each of these locations, we actually saw a yield decrease. So at Glendale, we lost yield relative to no cover crop or cover crop terminated at the normal timing. At Lexington, we lost a tremendous amount of yield. We had quite a bit of stand loss at Lexington, in part to animals. So we had more predation that way. But the other thing in here is we're also looking at our in-furrow components. And so we have the in-furrow fertilizer by itself. We have the in-furrow fertilizer and fungicide combination in the green. In the blue, we have the fungicide alone. And in the purple, we have nothing in the furrow. And so that's all graphed over that. And these are box charts. And these box charts indicate to us that if anything, on this delayed application, the fertility didn't help us out very much. When we get to the none to no cover crop or the normal removal timing, we're not seeing much separation at all in terms of the in-furrow giving us an increase in yield compared to not using in-furrow at all, which is very, very surprising to us. That's not what we expected. And furthermore, we thought for certain going into this that we would need a fungicide, that a fungicide would help us overcome some of the challenges that we see with the cover crop. That's not what we saw. In fact, a couple of times we saw that the fungicide and fertilizer combination together, actually reduced corn stands. Now, what we applied was by labeled rates. We didn't have excessively dry or wet springs overall. We were wetter, but we didn't plant into mud conditions. And so we should have had a system in place where we were testing that in-furrow treatment fairly, properly, but we still did not see the yield increases out of it that we were expecting. And so that was a surprise to us. So that delay in soil moisture caused us to reduce corn density, or the delayed in cover crop. We retained more soil moisture, we reduced our corn plant density, but we also reduced yield. And so we had challenges with that all the way around. And so what we've seen from this, a little bit of data from Dan's research, is that our cover crops do require more nitrogen. If we wait and side dress that nitrogen, so at V4 to V6 growth stage, that's better. We don't need quite as much nitrogen that way. We don't need to increase our seeding rates. I didn't show you that data, but for the most part, our seeding rates are good. And for whatever reason, our in-furrow fungicide and fertilizer did not provide a yield increase in our system. We have more to learn on that and more to study. One of the things I like to do is I like to look at some crimping on delayed applications. And this is a Central Kentucky farm that's doing that in their system. And so I think that would be interesting to look at as well. Then another thing in our small plots, one of the challenges by having heavy residue is it becomes a place where all the little animals tend to go and hide and eat on the corn. And so we may have more damage from that than what you might see in a large field where it's more spread out. But to this point, we know that cover crops do help us reduce erosion, and they do build soil structure based on previous studies. Even in this study here, they may hurt yields in some instances, although if we delay the nitrogen application at our higher nitrogen rates, we're getting equivalent yields from that. The cover crop definitely requires extra management. We've got to do a good job of getting it planted and established. We have to do a good job of terminating it, and we have to make these adjustments on nitrogen if we're going to try to maximize our yields on corn in this system. Having said all of that, I do think cover crops need to be part of our long-term no-till system. I think there are long-term benefits, such as the soil structure and erosion, that become more prevalent when we have cover crops in the system. And so ultimately, we have to balance the cost of establishing that cover crop with our long-term goals of improving soils overall. And I think that's one of our challenges going forward. So with that, thank you again for inviting me to speak. It is certainly my pleasure. I hope in the future I can attend this meeting again and do it in person. And at that point, we can all share a mate together. So thank you very much.
Perfecto.
Lucas, ahí estás.
Perfecto.
Great, very good discussion. I have a couple of questions from people who have been watching it. The first one is what crops you recommend as service crops for saline soils?
Primary crop we work with and that we prefer is the rye because it has a fibrous root system and it grows so extensively throughout the soil. The other small grains, wheat and barley, are probably acceptable as well. We've done a little bit of research with some clover, and there are some other species that are probably very good as well. The challenge is the economics. Right now, the wheat, the rye, maybe even the barley are probably the most economical of the crops to choose. And as a result, that's why most of our farmers are working with those crops. And that's why we're investigating those. So the research that I'm doing is looking at what are farmers using the most right now, and then how do we manage that to get better yield. I have some colleagues that are working on some of these other species for things like weed control and some things like that. But again, the expense of the others at this point, it makes it difficult for farmers to use them.
Perfecto, genial, Chad.
Great, Chad. Another two questions related to the issue of density with early termination and service crops. If you find any problem with the density in terms of implementation, and if you have faced any other time of problems because of the fallow that you have, the stubble that you found.
Okay. I think I follow the question well. And when we're seeding at about 60 kilograms of seed per hectare, that's giving us adequate density to cover the soil to capture excess nutrients. And we find that system works fairly well. We probably could get away or use a slightly lower seeding rate. But the problem is if we have difficulties in germination for some reason, that 60 kilograms per hectare seems to be the proper rate to insure against a low germination for some reason. Now, in terms of that spring termination, so when we terminate before we plant, probably the easiest way to describe that is if we go earlier, and so we terminate that 4 weeks ahead of time, like some of our farmers do, that causes the least amount of interference with planting the corn crop. But it also gives us less biomass. If we wait and we terminate the day that we plant, that causes the most challenges because we have animals, we have diseases and other things that give us challenges. But if we can successfully get the corn crop to establish, that extra biomass from that rye will help hold moisture in the middle of the summer. And so if our objective were to retain moisture throughout the year, we'd want to do the termination as late as possible, with the understanding that if we do it late like that, our risk of problems goes up quite a bit. And so if you look at most of the research done in North America on this topic, the balance between those two is about 2 weeks before planting. And so if we can get in and plant and terminate 2 weeks before planting, that seems to be the best balance between getting the benefits of the cover crop and reducing the risk of getting the corn crop established.
Great, Chad, thanks. I have yet another question. What's the change in the nitrogen dynamics by introducing cover crops such as rye before corn? If there's anything that that you could observe in the carbon-nitrogen ratio, if there, I mean, as regards nitrogen fixing.
Our answer is we need more nitrogen fertilizer to handle the additional carbon that we put into that system from the rye. And so the carbon, from an environmental standpoint, the carbon is a good thing. From an agronomic viewpoint, the carbon is a challenge because that carbon wants some of the nitrogen that we apply intended for the corn crop. And so that's part of what we found in this study is that if we put some of that nitrogen down as a 2x2, so about 30 kilograms per hectare as a 2x2, and we wait and put the rest of it on when that corn is about V4 to V6, then we don't need as much extra nitrogen. But if we put all of that nitrogen down at the time that we plant, we need as much as 70 kilograms per hectare more nitrogen. And so there's a massive difference in the amount of nitrogen we need to apply based on when we apply it. And also, this is important, our best yields occurred when we waited and applied the majority of that nitrogen at that V4 to V6.
Perfecto, genial.
Cool. Now, talking about nitrogen, there are many questions that relate especially to legume cover crops. Now talking about nitrogen. They ask whether you have tried legumes in dry areas, for example, or whether you have an experience with legumes as cover crops and what results you have obtained. For example, like Vettel.
Yes, so my colleagues, Hannah and Josh, whom I showed earlier in the presentation, have a location where they're looking at clover legume in mix with the rye. And so they're looking at rye by itself, and then they have this clover rye mix. And that clover rye mix appears to not inhibit the nitrogen fertilizer the way that rye by itself does. And so if we're looking at long-term nitrogen management, that might be what we need to consider, is actually mixing the legume in with the rye and getting our cover crop benefit, and then minimizing our nitrogen interaction afterwards. I'll go back to the reason most of our farmers aren't doing that yet are twofold. One is because the clover is more expensive than the rye. And then two, the farmers aren't really certain just what their penalty is. In other words, how much extra nitrogen they need to apply. I think if you look at that scenario from Dan's research, if you apply all of that nitrogen up front, well, in that case, you can probably pay for the seed cost of the clover, the legume, and then not plant or not apply the extra nitrogen fertilizer. So in that scenario, it would pay for putting clover out and then applying all your nitrogen up front. Of course, in Dan's study, if we wait and we apply that nitrogen at side dress, we no longer have the issue.
Great. One question that came up a lot is why is it there is this difference, or there was this difference in the nitrogen response when it was applied previously or on the site, and why is that difference? I mean, you see the difference at the beginning that is maintained, and when we have the site application at the end, the responses become equal. So what do you think this is attributed to, or maybe attributed to?
It's an excellent question, and it's one that is going to need a little bit further investigation. But what we think is happening is by the time we get to that side dress timing, enough of the rye biomass is decomposing at that point. Remember, we put down 30 kilograms of nitrogen per hectare in 2x2 in those studies. And so we think that was enough nitrogen to help the corn crop, but also help the rye decompose. And such that when we went out and made the side dress application, there just wasn't as much carbon there to tie up the nitrogen with that later application. That's what we think is going on. We've got to do a couple of more studies. And then again, I mentioned Hannah and Josh and Edwin. They're doing some studies in that area as well to confirm if that is the correct observation. And let me just say here, I think one really, really important thing with cover crops, because we get weeds that will grow over the winter, but those roots don't go very deep. I think it's extremely important that we're getting deeper roots, active roots in the soil for as long as possible without being detrimental to the cash crop, the corn crop. I think that's extremely important, and that's the main goal we're trying to achieve. And we can probably do that with several species. And so then the other challenge is, well, how does a farmer pay for that? Especially when the ag economy is very, very tight at the moment, when our margins are very narrow at the moment. How do we pay for that? And so it encourages the farmers to use the less expensive, the cheaper options right now, which tend to be those grasses, the rye, the wheat, or the barley.
Genial.
Great. Yet another question that comes up is what about the water consumption by this cover crop and how this can impact the corn yield, a species that has large yield losses when it is undergoing water stress. So how can the yield go down?
That's a very, very good question. And I think the biggest, from what we saw in Dan's studies, and so in our case, we were terminating that rye 2 to 3 weeks before planting or the day of. And in those two scenarios, the years that we've done this study, we have not seen that rye compete with the corn crop for moisture. But it's a very good question because we don't want the cover crop to become a weed crop. And I think where we would get into issues with moisture, in fact, if you go back and look at the late termination, so the termination done at planting, in our dry location, we actually retained more moisture with that bigger rye cover crop. And so it got big enough, it didn't compete with moisture early on. In fact, there are some farmers that tell us that that is one benefit of waiting and terminating the rye the day you plant or the day after you plant, is that actually those soils are a little bit drier in a wet spring. Now, that would also stand to reason that if it were a dry spring, maybe that big cover crop pulls off too much moisture early on. And that's not something we saw in our studies because we didn't have that environment in our studies. We had a wet spring at every location. The one location, we had a very dry summer, but we had a wet spring everywhere. And so in these wet springs, the cover crop actually, it didn't hurt planting, and it may have helped us a little bit when we were looking at that later termination timing. But the question is a good question because I'll go back to that weed question. I think if we were into a dry spring and we knew we were planting into drier soils, I think I'd want to terminate that rye cover crop as soon as possible so that it's not taking additional moisture out of the field. Again, we didn't test that, so I can't tell you that that's our data that says that. That's just what I think we need to do in that scenario.
Excelente, Chad.
Excellent, Jad. One more question that came up. Unlike what we see in Argentina, where we use cover crop not only for the soil but also to control weeds. In United States, did you find that they are useful to control weeds, or that's not a problem for you?
Great question. And my colleague Aaron Hiramoto that I showed earlier is really studying the weed aspect of it. And so she's strictly looking at cover crops from that perspective of how do I use cover crops to control weeds, maybe even eliminate a herbicide program. In our study, when we were terminating the crop, we didn't notice a massive difference in weed control with or without the cover crop. And so we needed to use we used we used the same herbicide program on both the cover crop and the no cover crop. And so, we terminated that cover crop and we applied soil residual herbicides in the spring. We came back with a post-emergence herbicide and we had pretty similar weed control. Now, one observation though that's been made, especially when you're growing rye, is that we have a reduction in a weed that's Coniza canadensis. In the States, we call it either horseweed or mare's tail. I'm sure there's a different name for it in Argentina. That is one that, at least in our region, is resistant to glyphosate. And so anything we can do to suppress that weed is usually helpful to us. And there have been some other studies that have shown that the cover crop does reduce the population of Coniza canadensis in the field. We didn't have much of it at our locations, but in those studies where that's been an issue, I think that's certainly helpful. And I think that question is spot on. So even if we don't save a herbicide application, it's much easier to control the cover crop than it is to control some of those weeds. And that's something that doesn't get discussed in here. So I think by putting the cover crop in the field, suppressing some of these difficult weeds, we actually find it much easier to go ahead and control that cover crop when we get ready to plant the corn crop or whatever other crop we might grow.
Excelente respuesta, Chad.
Excellent answer, Chad. Thank you. One more question. in the case of reducing nitrogen application, what proportion would you apply at an early stage on planting, or what other proportion would you apply later after planting?
It's a great question. And what we've seen in these studies is that we would put, depends on your method of delivery. If you're going to be able to apply it as a 2x2, and so in our case, well, excuse me, in your case, it'd be a 5x5, a 5 centimeter from the row and 5 centimeter deep. If you're going to do it in that method, then we would put about 30 kilograms of nitrogen per hectare in that method. And then we would wait until that V4 to V6 timing, and we'd apply the rest of it then. Now, here's one important thing. In our studies, most everywhere we did this, we were using a liquid form of nitrogen, so 32% urea ammonium nitrate. If you have to use urea in that system, which may be the case for many growers there, corn at that young is probably still okay. I would be concerned because you're waiting to that V6 to V8 timing. I'd be concerned that you may have more volatilization losses from that urea being applied. And so you might want to consider using something like agrotane on that urea if you're going to wait and do the application at that point. So that'd be something I would consider for that. It's not something we tested in this study here because we used a different form. Your other option would be to do it in furrow. And so now you're doing it right next to the seed. And if you do it that way, you really can't get above more than about 3 to 5 kilos of nitrogen per hectare in the furrow, because you don't want to jeopardize the integrity of the seed by putting too much nitrogen on that seed. And so in that case, and this isn't what we studied. We studied putting it 5x5, but if you did it in furrow, I'd still probably wait till the V4, V6 and put the rest of that nitrogen on at that stage. We have some other studies I didn't show today where that method worked pretty well. So, and I guess while we're on this, I understand what I'm saying here is what's working well agronomically. That may not work well logistically. That may be difficult to make a pass through the field and plant and put a little bit of nitrogen down as you plant, and then wait 2, 3, 4 weeks and come back later and put the rest of the nitrogen on. I understand that. But that is a very common practice here. It's one that helps us manage wet springs, and it's one that helps us reduce nitrogen loss overall.
Excelente, Chad.
Excellent, Jad. One last question. My questions. What are the different stages that occur in your research with corn? Do you see an improvement in the accumulation of nitrogen in the soil? And what would be the future of this research?
Great question, Lucas. So the last 2 years, we have harvested entire corn plants about a week before we would harvest them for grain. Well, when the corn plants still have some green color to them, but we're already at R6. And Dan has looked at nitrogen movement into the plant in all aspects of the plant to see if there were any differences at all in terms of how the corn plant took the nitrogen up and then distributed it into the plant. And what he found was from all of our different timings and cover crop and no cover crop and everything else, he found no difference at all by R6. And so the crop had what it needed in those scenarios. In terms of the soil, I think that's the next thing to investigate. That goes back to the question somebody asked earlier about, well, how much carbon is in the soil and how much is it tying up the nitrogen. We didn't really look at that aspect. We tried to measure it through the plant response and pulling plant samples. And with the plant samples, we didn't see anything. So I think the next step would be to try to pull the soil samples and look for an indication of carbon, nitrogen, before and after fertilizer application, and then through a few weeks out, just to get an idea about how that soil dynamic might be changing in there. So I think that's one area of aspect to go. And the other final thing, I just while it's on my mind, your soils are so impressive. They're so deep. They're grass-based. They're very, very productive. One of your biggest risks is wind erosion, and then certainly some, from heavy rains and such, that can be an issue as well. But if you've got the ability to put a cover crop, particularly something that has a deep rooting system in it, and hold that soil in place and build structure over time, I mean, you're already starting out way, way ahead of where we are, just in terms of what the basic soil looks like. They're so much deeper. They have the potential to be so much more productive than what we've got in this region right here. Putting a cover crop on top of it will just make, over time, I believe it will make for phenomenally good soil quality, and ultimately, eventually, phenomenally good yields.
Excelente, Chad.
Excellent, Chad. We want to thank you from Aapresid with your effort of making this presentation in English. And so we can learn, or we can think of how we can implement in our own region, or your advice. Do you want anything else? Do you have anything else to say to close this presentation?
Just thank you very much for the invitation. I would have loved to have been there in person, and hopefully when we all figure out this pandemic, hopefully in the future, I'll be able to come back and get to visit again. So thank you very much.
Listo.
Again, thanks, Chad, and all those of you who are participating in this presentation. I hope that everybody is